Okay. This is Michael's here.
What's up?
This is the last video for explaining, or the last video that will explain phase changes. A phase change is going from one phase to another, solid to liquid, liquid to gas. Easy. What is a phase change? Well, a phase change is the absorption of a heat without a change in temperature. For instance, this is 0 degrees. This is 100 degrees. So the phase change, this was the problem we did, where this is 0 degrees. This is solid here. This is solid liquid, and this is a liquid. So a phase change is a change in state, solid to liquid, where it absorbs energy without a change in temperature. That's what a phase change is. But what does it mean at the atomic level, the singular level, the particle level, the molecular level? Well, it has to do with potential energy. This is a solid, liquid, and gas. Remember, this is much more complicated than this, but this is a beginning. You can see that within that narrow space, those water molecules, there's 4 of them, can have a finite number of collisions per second, correct? And then it can't collide any faster.
It's more dense.
Well, no, yeah, but you can only have you can have maybe 10, 10 collisions per second, or, it can only be as powerful. Do you see that the size of the space limits the amount of friction, the amount of energy transfer from one particle of water to the other? You see that? I mean, it can only go so fast in the collisions. The collisions can only be so powerful, correct?
Yep.
Now, we know that this has energy. This has more. Increasing distance, vertical distance, is gravitational potential energy, correct, Mike? Okay.
Correct.
Well, it's similar with phase changes. This is a solid, liquid, and gas. When the number of collisions change within the solid, you get a temperature change, because temperature is proportional to collisions. The more collisions, the greater the temperature, correct? So the number of collisions, as they increase here, I'll increase the temperature, correct? Now, when it says, okay, that's it, I can't have any more collisions at this distance. It's not working for me. So let's increase the distance, okay? You maintain the number of collisions, but you increase the distance between them. So the number of collisions are staying the same, therefore, I'll write solid to liquid water, okay? Time, temperature, -20, 0, 100. Okay? Yes? So this is no temperature change, the constant temperature. The number of collisions are constant. But what's changing? There is something changing. Well, the energy that's going in here is increasing the potential energy. The heat of fusion is small, going from a solid to a liquid, because it's a small change in distance. Correct? I think the heat of fusion for water is 334,000 joules per kilogram. Right? Relatively small. Okay? All right. So the number of collisions going from here to here remain constant. So I can say it's a constant temperature, correct? But the distances are changing. Yes? I increase the distance, aren't I increasing the energy? Increasing the distance, increasing the energy. So the energy is going into increase of potential energy. Get it?
Got it.
Good. This one is going to be the same thing when I get to here. This is the heat of fusion. This is the heat of vaporization. You can see that this one, even though I didn't draw it on the graph, but this is much longer. It takes longer for that to go in because look, this is going to be the heat of fusion. The heat of vaporization will be 2,260,000 joules per kilogram. 10 times, not quite 10 times, larger. Okay, 8 times larger. Okay, yeah, approximately. So you can see that change in temperature is constant. Temperature, constant. Temperature, constant. Yes? But what's different? The increase of distance. Look at it this way. Potential energy, gravitational potential energy, or thermal potential energy. You can call it thermal potential energy. Can we do that? Can we call it thermal potential energy? Sounds a little weird, but it's the idea. I'm increasing the average distance between the molecules. Solid, liquid, and gas. Have a great day. Drive home safe.